Hi everyone, welcome to Cram for Chem, where I help you study for as much chemistry as possible in a short amount of time. In this video, let's talk about the things that make up our universe, which are elements and compounds. First of all, elements and compounds are both pure substances, which means that all the particles throughout a sample of the same element or the same compound all have the same identity. Let's talk about elements first. Elements are the building blocks of matter. You can combine elements together to make different things, but they cannot be broken down into simpler substances by chemical or physical reactions. All elements that we know of are on the periodic table, which is a chemist's most important tool. To understand elements, we'll study these topics: atomic structure, the periodic table, isotopes and average atomic mass, and diatomic elements. Let's start with atomic structure, because atoms are the building blocks of matter, which means that everything, all matter in the universe, is made up of atoms. Atoms are made of three types of subatomic particles: protons, neutrons, and electrons. At the center of every atom, we have the nucleus. The nucleus includes protons and neutrons. Both protons and neutrons have a mass of 1 atomic mass unit, or AMU. Each proton has a positive 1 charge. You can remember this because protons and positive both start with P. Neutrons have no charge, or 0 charge. Neutrons are neutral. Outside the nucleus, we have the electron cloud, and this is where we find the electrons. Electrons have no mass, and each electron has a -1 charge. Let's go back to the periodic table and see what information it gives us about the protons, neutrons, and electrons of different elements. In each element's box on the periodic table, you'll see this information. The number on the top is called the atomic number, and it represents how many protons the element has. The number on the bottom is the average atomic mass of the element. For every element, the number of protons and electrons are equal, as long as the element is in its neutral state. For example, aluminum has an atomic number of 13. That means aluminum has 13 protons, and therefore 13 electrons. Because electrons have no mass, all the mass from an atom comes from its protons plus its neutrons. For aluminum, since it has a mass of about 27 and it has 13 protons, that means the leftover mass comes from neutrons, so it has 14 neutrons. Atoms of the same element will always have the same number of protons. For example, all aluminum atoms have 13 protons. However, they can have different numbers of neutrons. That's going to lead us into isotopes. Isotopes are atoms of the same element that have different numbers of neutrons, which means that they have different masses. Here's an example. Carbon-12 and carbon-14 are both carbon atoms. All carbon atoms have 6 protons because the atomic number of carbon is 6. But carbon-12 has a mass of 12, which means that it has 6 protons and 6 neutrons, while carbon-14 has a mass of 14, which means it has 6 protons and 8 neutrons. Now, you might have noticed that the mass shown on the periodic table is a decimal number. That's because this mass takes into account all the isotopes and is the average atomic mass. So how do you calculate the average atomic mass? Here are the steps. First, you identify the relative abundance of each isotope, which is usually given as a percentage, and convert it into decimal form. Then, you multiply the relative abundance by the isotope mass. Finally, you add up all the products. This is what the formula looks like. Let's do an example. A sample of chlorine contains 76% chlorine-35 and 24% chlorine-37. What is the average atomic mass of chlorine? We're going to take the 76% and write it as a decimal, so 0.76. Then, we multiply it with the isotope mass, which is 35. Next, we do the same thing with the other isotope and add that. We'll add 0.24, which is 24% written in decimal form, multiplied by the isotope mass of 37. If we solve this equation, we'll find that the average atomic mass of chlorine is 35.48 AMU. Sometimes, instead of being given a word problem, you might be given a mass spectrum, like this one. A mass spectrum is a graph that will give you the same information as the word problem we just solved. Each bar on the mass spectrum is an isotope. From the mass spectrum of chlorine, we can see that it has 2 bars, so 2 isotopes. For each bar, we can read the isotope mass from the x-axis and the relative abundance from the y-axis. This first isotope has a mass of 35 and a relative abundance of 76%. The second isotope has a mass of 37 and a relative abundance of 24%. Once you have all this information, you can do the exact same math to find the average atomic mass. The last thing that I want to talk about for elements is diatomic elements. These are 7 elements that always exist as diatomic molecules, which means that in the pure element, the atoms are always bonded together in pairs. These diatomic elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. An easy trick for memorizing the 7 diatomic elements is to keep thinking the number 7. You go to element number 7 on the periodic table, which is nitrogen. From there, you draw the number 7 down to iodine. This gives you 6 elements in total, so you need 1 more, and that's element number 1, hydrogen. Let's move on to compounds. Compounds are 2 or more different elements chemically bonded together. Here are some that you're probably familiar with. Water, or H2O, which has 2 hydrogens and 1 oxygen bonded together. Carbon dioxide, and sodium chloride, or table salt. For compounds, we'll talk about percent composition and empirical and molecular formulas. Let's start with percent composition. Percent composition is the percent by mass of each element in a compound. To find the percent composition, you take the mass of each element in the compound, divided by the total mass of the compound, and multiply by 100. Let's use water as an example. What is the percent composition of H2O? To solve this, I'll first find the total mass of water. I'll do 2 times 1.01 because there are 2 atoms of hydrogen, and each atom of hydrogen has a mass of 1.01. Then I add the mass of oxygen, which is 16, so the total mass of water is 18.02. Then I'll find what percentage each element takes up. For hydrogen, I'll take the mass of hydrogen, which is 2 times 1.01, and divide by the total mass of water, which is 18.02. Then I'll multiply by 100. The percent by mass of hydrogen is 11.2%. For oxygen, I'll take the mass of oxygen, which is 16, and divide by the total mass of water, which is 18.02, and multiply by 100. The percent by mass of oxygen is 88.8%. For the answer to this question, I would say that the percent composition of water is 11.2% hydrogen and 88.8% oxygen. Now let's move on to empirical and molecular formulas. The empirical formula of a compound is the simplified chemical formula. It shows the ratio of atoms in a compound. For example, glucose has the chemical formula of C6H12O6. The empirical formula, or the simplified formula, is CH2O. The molecular formula is the original chemical formula. It shows the actual numbers of atoms in a compound. The molecular formula for glucose is the original C6H12O6. A skill that chemistry students should know is converting percent composition to empirical formula. This process has 4 steps, and you can remember them with the mnemonic, grandmother does math. Grand stands for grams. You want to take the percentage and write it as grams. Mother stands for moles. Convert grams to moles. Does stands for divide. Divide everything by the smallest number. Math stands for multiply. Multiply until you get whole numbers, which you'll use for your subscripts in the chemical formula. Here's an example. Rust consists of 70% iron and 30% oxygen by mass. What is the empirical formula of rust? Step 1 is grams. Instead of writing 70% and 30%, I'm going to write 70 grams for iron and 30 grams for oxygen. Step 2 is convert to moles. I'll do this by taking the grams and dividing by the mass from the periodic table. This gives me 1.253 moles of iron and 1.875 moles of oxygen. Step 3 is divide by the smallest number. Between 1.253 and 1.875, 1.253 is the smaller number, so I'll divide both numbers by 1.253. This gives me 1 and 1.5. The final step is multiply to get whole numbers. The 1 is fine, but the 1.5 still has a decimal. To get rid of the 0.5, I'll multiply both numbers by 2. Now I have whole numbers for everything. These whole numbers become the subscripts. The empirical formula for rust is Fe2O3. The last thing I want to talk about in this video is converting from empirical formula to molecular formula. Now remember, empirical formula is the simplified formula and molecular formula is the original. So basically, we want to know how to unsimplify a chemical formula. These are the two steps. First, find the mass of the empirical formula. Then, you divide the actual mass of the molecule by the mass of the empirical formula to find the factor that will undo the simplification. Here's an example. A compound has the formula CH3. If the molar mass of this compound is 30.08, what is the molecular formula? What I'm going to do is first find the mass using the empirical formula, CH3. That's 1 carbon, so 12.01, plus 3 hydrogens, which is 3 times 1.01. This gives me a total of 15.04. Then I'll divide the molar mass of 30.08 by the mass from the empirical formula, and this gives me 2. That means to unsimplify this formula, I need to multiply all the subscripts by 2, and I get C2H6. I hope this video was helpful. Thank you so much for watching.